Welcome back to 30 Days of Physics with Miss B, and we're moving right along into momentum. Momentum is a useful quantity to consider when bodies are involved in collisions and explosions. Momentum is a vector quantity, which means it has both size and direction. The linear momentum of a body is defined as a product of its mass and its velocity. Momentum is equal to mass times velocity. The units of momentum are therefore kilogram meters per second. These units are equivalent to the unit newtons seconds, which refers to Newton's second law. The rate of change of momentum of a body is proportional to the applied force and takes place in the direction of the force. Newton's second law, represented mathematically, indicates that F is equal to mv minus mu divided by t, where, with a little bit of transposition, Ft is equal to mv minus mu. mv minus mu represents a change in momentum, and since Ft has units of Newton seconds, this explains why kilogram meters per second is also equivalent to Newton seconds. Please note that F stands for force, T stands for time, M stands for mass, V stands for final velocity, and U stands for initial velocity. In the case of collisions and explosions, the conservation of linear momentum is applied. It states that in a closed system, when two or more objects act on one another, as in a collision, the total momentum of the bodies remain constant, provided no external forces act on it. For example, friction, where m1 v1 plus m2 v2 is equal to the sum of m1 and m2 times the final velocity of both objects. Please note that m represents mass, v represents velocity. Please note that the little numbers at the bottom corresponds with which variable you choose first or second, as will be seen later on. There are two types of collision, elastic and inelastic collisions. Elastic collisions are defined as one in which there is no loss of kinetic energy in the collision. In such a collision, the total initial kinetic energy is equal to the total final kinetic energy. In inelastic collisions, the kinetic energy is changed to some other form of energy in the collision. In this type of collision, the total initial kinetic energy is not equal to the total final kinetic energy. Please note that momentum and kinetic energy are not the same. They are both related to an object's velocity or speed and mass. Momentum is a vector quantity that describes the amount of mass in motion, while kinetic energy is a scalar quantity, and it is a measure of an object's energy from motion. When we calculate the momentum of a body, it is done as if in a closed system, since all other forces acting on the object are ignored. Here are some tips on how to answer momentum questions. Draw simple diagrams that match the question. Assign positive signs for velocities moving right, east, or north. Assign negative signs for velocities moving left, west, or south. Do note that this is totally dependent on you. So if something is moving right and you would like to give it a negative sign, then whatever is moving left must have a positive sign. But I like doing it this way. If a 5 kilogram toy car is moving with a velocity of 2 meters per second, what is its momentum? Well, You have mass of 5 kilograms. You have a velocity of 2 meters per second. All you have to do is find the product, and there you have it. You get 10 kilogram meters per second. I hope that is what you got. Here's another question. A 1 kilogram ball moves with a velocity of 2 meters per second. It collides with another 1 kilogram ball that is at rest. What is the final velocity if both masses move off together? Hey, you can pause this video and try it for yourself. Here's the answer. If we consider everything in a closed system, then the momentum before will be equal to the momentum after. Using the equation as previously stated, you would have 1 kilogram times 2 meters per second plus 1 kilogram times 0 meters per second. 0 meters per second is simply because the 1 kilogram mass in blue is at rest. Anything at rest has no velocity. All equal to 1 kilogram plus 1 kilogram. So both masses are now considered as one whole mass times final velocity. Some simple transposition should take place where you divide 2 kilogram meters per second by 2 kilograms and you get 1 meter per second for the final velocity. Hey, I hope you got 1 meter per second. That means that you're on the right track. Here's another question. A body of mass 2 kilograms moves to the right at 5 meters per second. It collides with a body of 1 kilogram that is moving to the left with a velocity of 20 meters per second. After the collision, the heavier body rebounds with a velocity of 2 meters per second. Find the velocity and direction of the 1 kilogram body directly after the collision. First, you have to start with drawing your simple diagram like how I have here. Note well that if you have velocities moving in the opposite direction, one of them is supposed to be negative. So pick the one that you would like to be negative. Would you like the ones moving to the left to be negative or the ones moving to the right to be negative? I prefer the velocities moving to the right to be positive and those that are moving to the left to be negative. My preference. Choose yours. Alright, so if you consider this in a closed system where momentum before is equal to momentum after, in this case, you would have m1 v1 plus m2 v2 equal to m1 v1 plus m2 v2, because in the aftermath, you have some rebounding happening. So because the larger object rebounds, we have both of them having their own velocities. So the masses did not stick together. They actually just bounced off of each other. Now, picking a mass first means you have to match up that mass with its velocity. In this case, 2 kilograms times 5 meters per second plus 1 kilogram times negative 20 meters per second will be equal to 2 kilograms times negative 2 meters per second plus 1 kilogram times v2. We would like to find the velocity of the smaller object. Now doing some algebra, we get negative 10 kilogram meters per second is equal to negative 4 kilogram meters per second plus 1 kilogram v2. And finally, after all of that, we end up finding that v2 is equal to negative 6 meters per second. You drop the negative sign and you have your value. And for me, my left has always been negative. So if I get a negative value, I know that the answer is stating that the object is moving to the left. Alright, so the 1 kilogram body moves to the left with a velocity of 6 meters per second. Alright guys, I hope this helped. Thank you for watching 30 Days of Physics with Miss B. See you tomorrow for day 11. Bye.